So we divided mean square between groups by mean square within groups, 8.3 by 1.22. I got 6.8. That's our F. We worked hard for it. That's ours. We need to compare that to a critical value for F that you get from your table. And I sent you a way to go and get your table out. So let's look at your table. Let's see. Your table should look like my table. So I had to go get my table as well. So we want an F on 2 and between group and within group degrees of freedom, 2 and 6 degrees of freedom. We need a critical value. So we go up here. This is degrees of freedom between group 2, degrees of freedom within group 6, and I get the critical value of 5.14. So let's go back over here, 5.14. So this value right here is 5.14. Anything in the tail, anything out here is the region of rejection, and we reject the null. Anything over here is the region of non-rejection, and we fail to reject the null. Now remember that in ANOVA, the null hypothesis is that mu, all the mu's are the same. So mu for aspirin is equal to mu for ibuprofen is equal to mu for the placebo. All the means are the same as one another. No differences. So we go back over here and we look at RF, and where does it fall? Does it fall over here in the region of non-rejection or over here in the region of rejection? So is it above 5.14 in the region of rejection or below 5.14 in the region of non-rejection? Well, 6.8 is bigger than 5.14. So we're going to reject that null hypothesis and say that there are significant differences between aspirin, ibuprofen, and a placebo in the time it takes to relieve headache symptoms. So aspirin versus ibuprofen versus somewhere up in there, there's some kind of difference between these three groups. Now, F is an omnibus test. We don't know where the difference is, but we know that somewhere up in there, when we threw them all in, there's some kind of difference, more than we would expect, some kind of variability between those means. The means are more variable than we would expect natural, normal, random variation to be in a sampling distribution where the mu's were all the same like this. It doesn't seem very likely that this is the case. It seems more likely that somewhere in there are some differences, and we really don't know where. And that's an ANOVA. So I'm going to give you a practice problem to do.